So today we're going to talk about inverse functions. So I want you to take a look at this graph. Those of you that had me for geometry should recognize it because this is the way I taught it. So what information can you gather from this graph? Go. Okay, so one at a time, raising your hand, and then... Ooh, that's a bad word. It's a reflection, right? It's a reflection. It's being reflected. Good job. What else? Yes.
One blue and one green.
Okay. Can we get past kindergarten? Okay. He said one's blue and one's green. Yes, we know our colors. Okay. Ryan.
They're congruent in size.
They're congruent in size. Good. How do you know?
They each take up like the same number of the little block things on the graph, up the same number of points.
Okay. Good. We could also measure them, right? But they do have the same area. You're right. Anything else? They do have the same... Actually, their slopes are inverses. Right? Yes. It's not going counterclockwise. It's actually just a straight reflection over the line. That would be called a what? Do you remember? It's a certain kind of... It's a rotation. Good. Good. Nice vocabulary, Janelle. You had a really good teacher. Awesome. Thank you. Okay. So it's a reflection. What would we call this line right here? Almost. You're getting there. Line of reflection. Good job. Kind of the same thing as line of symmetry, right? Because they are symmetric, but they're symmetric in a specific way. We're going to talk about that right now. Check this out. So let's do the green one first. We're going to label it A, B, C. A, B, C. What's that first ordered pair? Of A. 1, 2. And B would be 1, 5. And C would be -4, 2. What about the blue triangle? Remember this from geometry? Check. Wait, hold on. I haven't done it yet. Remember, it's reflected over y equals x.
Oh my gosh.
Okay. Oh my goodness, they're making us do geometry and algebra together? How dare they?
I got warned about this.
You got warned? Okay. So wouldn't this be A prime, and this would be B prime, and this would be C prime? Why are we being negative? Are we allowed to say that in Mrs. Mahler's class, Evan? Evan, I'm going to turn your phone upside down right now. You ready for this?
Yeah.
Okay. Evan, all on Evan. Evan, what is A prime? What are the coordinates?
2.
Evan. Evan, what are the coordinates? 2, 1. Five, 1. No. 2, -4. Huh. Take a look at the green.
I've already figured that out.
X and Y are interchanged. Ties it all together, doesn't it? Right? Reflection over the y equals x means I can switch the x and the y. They interchange. All right, let's take this and let's talk inverses. Okay, pencils down. Everybody paying attention. All right, find the inverse of f of x if f of x equals x minus 3 over 5. Okay, so here are my steps. Number 1, I'm going to replace f of x. What's a more comfortable way of writing that you guys like a lot better? Y. Y equals x minus 3 divided by 5. All right, just as I did here, I'm finding the inverse. These are inverses of each other, correct? So what did we do? on these points? Didn't we just interchange them? So let's interchange x and y. X equals y minus 3 over 5. Now I need to multiply both sides by 5 to solve for y, right? And I get 5x equals y minus 3. Now a lot of you can skip a lot of steps right here, but I'm not going to skip steps. I'm going to add 3 to both sides, and I get 5x plus 3 equals y, or if I put this into function notation, I just found the inverse function of x, which is equal to 5x plus 3. Questions? Evelyn? Why didn't I change what? The 5x to a y. Okay, so I interchanged my x and my y. I solved for y. So this is my new line that's reflected. Okay, that's a valid question. So doesn't this also equal y equals 5x plus y? Sorry, plus 3? Same thing, right? Don't we normally write y as, in function notation, f of x? But we're not talking about the original function. The original function is this. So this is the inverse of this. They're inverses. As soon as I switch x and y, right here, as soon as I switch these, I now have the inverse function. Ryan?
So when you write the inverse function, you put like x, and then negative 1 like the exponent. Will that ever change, or is it always in function?
That's the notation you'll always see from now on.
Okay.
This means inverse function. Okay? That means whatever this is, the inverse of it is reflected over what? What's that line? What's this line? Line of reflection, which is y equals x, right? Okay, let's see if doing the next screen will help you guys. I would rather us do the next screen, and then I'm going to have you copy it. Evan, please put your pencil down. So now I'm going to graph the function and its inverse. So when I graph, let's make this one blue and this one green. Which one should I start with?
I like green.
I like green too. Really? You want to graph that like that? I don't. Let's graph that. How do I graph that? Up 3. Up 1, 2, 3, 4, 5 over 1. Or maybe some of you do down 1, 2, 3, 4, 5 over 1. There's our first line. Actually, while I've got it on there, let's do a line of reflection. So now I need the line of reflection, unless we say otherwise, yes. Okay, so right there is that graph right there. X comma y. I'm just going to do a table of values, just a real quick one to make a point, okay? So what's my first ordered pair that I just have to see from looking at this?
5 and 3.
0, 3. Right? Isn't this always your y-intercept?
Yeah.
Even with those really crazy functions that we were graphing in the last chapter, right? Wasn't that always my y-intercept? Okay, going right back to roots. Let's look at this. What's another point I could write? 1, 8. Okay, so I don't want to graph that. Couldn't I just use the point? So if 0, 3 is my inverse function, what's my function? 3, 0. And if 1, 8 is my inverse function, what's my function? 8, 1. 3, 0. 8, 1. There's my other line. Look at that. All make sense? Okay, let's go back and copy these down completely with the steps so you guys have everything. All right, let's look at the next one. Try this one on your own. Okay, so my first step is to replace f of x with y so it looks nice and friendly, right? Then I need to interchange x and y. So as soon as I do that, I've now created a what? An inverse function. Okay, so I've got x equals negative 1/2 y plus 1. Solving for y, I need to get rid of that positive 1, subtract 1 from both sides. Then I get x minus 1 equals negative 1/2 y. How do I get y by itself? Divide or multiply by negative 2. Multiply by a negative 2. So when I do that, these cancel, correct? I distribute, and I get negative 2x plus 2 equals y. Or my inverse function of x equals negative 2x plus 2. Questions on that part? Everybody okay? Uh-huh. Same thing, right? That's just like saying Mrs. Mahler is 37 or 37 is Mrs. Mahler. Same thing? Okay, you guys ready? Okay, I'm going to graph it now. So these are my two functions, my regular function and my inverse function. This time, I see that they are both graphable. Right? So let's start with this one. X comma y. What is the first ordered pair that I should recognize? 0, 1. 0, 1. Then where do I move? Up 1, over in the negative direction 2, or down 1 and to the right 2, whichever you like. There's my first line. Let's plot one more point. 0, 1, or put one in the table. What's the other one? 2, 0, right? All right, let's move on to our inverse function, x, y. What's the first one I should be putting here? 0, 2. Oh, and looky there. Look it, they're inverses of each other. So 0, 2 is right here, and then I'm going to move up 2 over 1 or down 2 over 1. So this other point is 1, 0. Oh, look there. Those are also inverses of each other. Now, I just have to graph that line. Kind of poorly graphed. A little bit better. Can you see that they're inverses? Not really, right? What do I need to do? Let's do our line of reflection. Now do they look like inverses? Yes, they do. Questions? Because this is always my y-intercept. Always. Last chapter 2. Every single equation, the constant is always the y-intercept. Just like when you were back in Algebra 1, where did you begin? Remember? This is y equals mx plus c, awesome. Where did you always begin when you graphed a line? At b. What does b stand for? The beginning, or the y-intercept, right? Yeah. So y, this is always the y-intercept. Yes. Nope. Doesn't matter which one you start off with. Just graphing 2 lines. Or I could have just graphed 1 and then did the inverse of the points, right? Okay, moving on. pencils down. I've got one more thing to talk to you guys about. So two functions, f and g, are inverse functions if and only if both of their compositions are the identity function. What does identity mean? The same, right? Identity means the same. So I've been proving, like for instance, it says that we've got f of x and g of x. If I were to interchange the x and the y, I should get this function, right? Or if I were to graph this, then I reflect it over y equals x, I should get that one, right? Well, this one uses what we did yesterday in your homework. If I use the composition, I should get the same thing. So the composition of f of g would be f of g of x. And the other composition, I'm just going to get rid of this. And put this on top. And the other one should be g of f of x. Okay, so pay particular attention right now. I'm going to make colors. F of x is going to be blue, g of x is going to be green. So I'm going to start with f of x. I'm finding this is much easier to just put the placeholders there. So this is the function of whatever's in here, right? Equals, what is the function of x? The f function? 3x minus 3. What do we normally do when we substitute in functions? Substitute in for that x, right? Let's do the same thing over here. So I have g of whatever goes in here equals, what's my function for g? 1/3 x plus 4, which should equal 1/3 of whatever I substitute in there plus 4. All right, so what do I substitute in here? G of x. What is g of x? 1/3 x plus 4. So what goes in here? Is this helpful? And what goes in here? 3x minus 3. And what goes in here? All right, let's finish this. So 3 times 1/3 x is just x. 3 times 4 is 12 minus 3. So this one is x plus 9. This one comes out to be 1/3 times 3x is just x minus 1 plus 4. X plus 3. These are not inverse functions. Not an inverse function. Let's see if it'll give me my exclamation mark. Yep, not an inverse function. Copy that down. Please. Please do so. That's not my room. I had to translate. Translate my desk that way. What?
I solved the first one thinking I had to do the whole thing where I found it and solved it. Not like a whole sheet of paper.
Good. Okay, guys, ready? All right, 5, 4, 3, 2, 1. I need to get to homework answers. Thank you. And it's frozen. Thank you. Are we all good now? All right, so this one's green, and this one's blue. And I'm going to start out with blue. F of whatever G is equals 3/4 x minus 6. Then I'm going to substitute whatever x is. You see, Boston, what I'm talking about? This is what I want to see right here. Okay? I'm going to do the same thing over here. G of whatever f of x is should be 4/3 x plus 8. Then I'm going to substitute in for x and add 8. Over here, my g function is 4, oops. My g function is 4/3 x plus 8, 4/3 x plus 8. Over here, my f function is 3/4 x minus 6, 3/4 x minus 6. Finish off over here. These cancel each other out, and I just get x plus 6 minus 6 equals just x. Over here, I get x minus 8. 4 times 2 is 8, plus 8, which is x. Are they identical? Yes. Are these inverse functions? Yes. Yes. Inverse functions. Why do I hear packing up? No, I want to know that they're inverse functions. Don't be lazy. Okay, questions on this? Okay, on the next screen, I want you guys to be careful. I don't want anybody doing anything. Your hands should be down. You should be ready to just pay attention and talk to Mrs. Muller. Right? What did you learn today? Inverse functions. Nobody writing, nobody flipping over, nobody finding their pink paper, just paying attention. How can a graph describe an inverse function? Okay, when they're inverses, right? What about it just simply being what, Tricia? A reflection, right? That's how a graph proves that it's an inverse. It's a reflection. The person next to you is absent. How would you explain how to find if two functions are inverses algebraically? They're both the same answer of what? What is that? What did we do yesterday? Starts with a C.
Operations on,
Not conjunction. Composition, right? Composition of functions proves it algebraically. So now here's those key words on your assignment sheet. Now feel free to pick up that pen. Inverse functions are blank over the graph of blank equals blank.
selected over the graph of S equals 1.
Good. Good job.
Good job.
Fantastic.
Evan.